would request everyone to kindly get seated for the next session. We would request everyone to please come back and get seated for the next session.
Hello. Hello. We'll continue in 5 minutes. Please come back.
Our next session delves into integration of AI and architecture, where we explore how artificial intelligence is revolutionizing architectural design, urban planning, and construction methodologies. We would like to now introduce our panelist, co-convener, Professor Uzma Khan. Uzma Khan is a conservation architect with an experience of more than 8 years in the domain of academics, research, and collaborations. She graduated in the discipline of architectural conservation with honors in 2016 from School of Planning and Architecture, Bhopal, and received National Fellowship from AII, India Council for Technical Education, Government of India from 2014-2016. Uzma Khan has taught undergraduate and postgraduate students in the discipline of architecture, structural systems, history, and cultural heritage. She has presented her research papers at several national and international conferences, namely UNESCO, Benecon Consortium, Conference at Italy, and mentored international exchange students such as Angarwadi and internship programs. She has also been part of technical committee for international conferences. Her research expertise are urban conservation, heritage management, shared heritage, and cultural studies. In recent years, she has published her work on shared heritage, architectural pedagogy, and arts of Delhi. Presently, she is exploring the interdisciplinary domains of gender and public spaces, livability in urban cores, and sites of Sufism as part of her ongoing research initiatives. She employs user-centric approaches, fostering community-driven solutions and contextual narratives in her approach. Her experience over the years has allowed her to enhance learning collaborations that manifest analytical skills, technical knowledge, and critical thinking approaches in the practical and theoretical domain alike. Since learning is a continuous endeavor for her, she wants to combine her existing knowledge from her experience into future projects to provide sustainable solutions streamlined at interdisciplinary approaches towards build heritage management and strive for a holistic vision towards community development. We would request Professor Uzma Khan to address the dais, please.
Thank you for the wonderful introduction. So the panel which is there right now is integration of AI and architecture, methodology and frameworks, transformation in built envelope through digital mechanisms. The theme integration of AI and architecture, methodology and frameworks explores how artificial intelligence, AI, is transforming the way we design and build. AI offers architects tools to analyze data, predict outcomes, and optimize designs in ways that were previously unimaginable. From automating repetitive tasks to generating complex structures, AI is making the design process more efficient and innovative. This theme focuses on the methods and frameworks that guides the integration of AI into architectural practice, ensuring it complements creativity rather than replacing it. It highlights how AI can assist in sustainable design, urban planning, and creating spaces tailored to human needs. By combining AI's analytical power with an architect's vision, the field is evolving to address modern challenges and push the boundaries of what's possible in design. I request our esteemed speakers, Satakshi Sharma, architectural designer, Ronit Riley, Architect, New York, Dr. Mehfooz Rahman, Assistant Professor, NSUT, Delhi, Khushbu Davda, Founding Partner, Studio Emergence, Mumbai, to proceed for the stage and take the dais. I request the audience to give a huge round of applause to our esteemed guests and speakers. I now request Shatakshi Sharma, architectural designer, Ronit Riley, Architect, New York, to please begin with her presentation. Shatakshi Sharma holds a bachelor's in architecture from Ayojan School of Architecture in Jaipur, India. She has worked at Design Forum International Delhi on projects such as Vanijya Bhavan, NIT Delhi, Dakshineshwar Skywalk, Uttarakhand High Court, as well as large-scale housing, malls, and urban planning initiatives. While in India, she also contributed to UNICEF's safety education in flood-prone regions of rural Bihar. Shatakshi later earned a Master's in Advanced Architectural Design, AAD, from the University of Pennsylvania, where she was a part of the Polyhedral Structure Lab and worked on developing robotic fabrication techniques. She also contributed to projects like Sustainable Refugee Housing with UNHCR and the resettlement of Gur district in Mongolia, along with her design studio projects. Currently, an architectural designer at Ronit Riley Architect in New York, Shatakshi's work includes courthouses, skyscrapers, and community centers, with contributions to some iconic NYC projects. Along with being a designer, she is also a lead green associate and accessibility and wayfinding expert. I now give the dais to Shatakshi and to ask her to continue with her presentation. Thank you. Just wait. Where is your presentation, Shatakshi? Yeah. Yeah, just a second. Just a second. Yeah, just yeah, that's what. कहाँ से? एक मिनट. No. Wait. Wait. No, it's download. It's downloaded only. It's opening in Chrome. I'll just open in. Yeah, wait. And control. Yeah.
Hi, good morning, everybody, and thank you for such a wonderful introduction, Uzma. And also thank you, everybody, for being here and giving me an opportunity to share my work with you all. So let's begin. So the title of my presentation is From Blueprint to Building, Impact of Artificial Intelligence on Architecture. In the morning, the keynote speaker, Mr. Monish, has explained how architecture has evolved with the advent of AI and machine learning. So now when we talk about future, we talk about two things. One is utopia and one is dystopia. So either way, we imagine AI and machine learning to play a big part of both these visions, good or bad, but both these visions are incomplete without artificial intelligence. So there are two streams of artificial intelligence that relate directly to architecture and that we are working on in the commercial industry as of now. So one is 3D modeling, and then the other one is robotics. With 3D modeling, 3D modeling includes like BIM technologies, which all of us are aware of. Then it also includes computational design. It also includes AR, VR, and robotics is the real-world integration of all of these techniques. AI has certainly a lot of advantage. So one of the biggest advantage is the ease of collaboration. It's very easy to collaborate between disciplines. Like as an architect, I use a lot of BIM 360 on Revit, and it's so convenient for me that the mechanical consultant can use it simultaneously as I do, and the structural consultant can also use it simultaneously. So, oh, it should be closer. Am I better now? Yeah. So the ease of collaboration is what I was talking about, and so all my consultants can use and update the model at the same time. So it's very QA/QC is also, which is like quality control, is also very important and very easy in this case. If I'm making a structural error in my design, my structural engineer can point me out right then and there that, hey, you know what, maybe we need to update this. Then the second advantage is fast simulation, which is, of course, like all of us are aware of, Midjourney, Adobe Firefly. I can generate multiple scenarios at the same time and get inspired from them. Then more work done in less time, that's a given for sure. And that's sustainable. I print way less now. I waste way less paper than I used to as compared to, let's say, 7 years ago. So that's an advantage. I think that's a very big advantage. Also, being an environmentalist, I think that is one of the biggest advantage. So now, when we look at these slides, on this side is what you see is okay. On this side is what you see is the part that we use as designers, and on the other side is the part, the application of AI and machine learning in construction industry. So in design industry, it's used in generative design because we can give specific parameters, we can input specific conditions, site conditions, climate conditions, construction conditions, and it's going to get us a lot of simulations based on our request. Then energy efficiency optimization. AI basically can, it's also related to performative environment. So AI can actually analyze the environmental data, and then it suggests design modifications, or it can help you design. So another thing that's very important when it comes to energy efficiency is the placement of fenestration, the placement of your doors, how we can make most use of the natural resources that are available to us, i.e. sunlight and air in most cases. So then the other one, we are all aware of it, it's called building information modeling. That's used extensively. Then smart cities and urban planning. AI can also govern the, AI can also help us analyze the traffic patterns, air quality, public transport usage, population density, green spaces, infrastructure, and so on. So also being an accessibility expert, I think it's very important for us to make cities and places and buildings accessible to people who are otherwise disabled. And for instance, a person who's on wheelchair and who is blind should comfortably be able to move in a city without any help. To me, that's utopia. Then virtual reality and augmented reality, we have talked enough about it. And now let's go to the construction part of it, which is AI and construction robotics. So we all are aware of drones and the surveillance that they're used for. And then it can be used for 3D printing, it can be used for bricklayering, and then it can be used for site inspections. Then construction automation. So AI could also be predicting delays, managing resources, and ensuring timelines that we should be adhering to. And it could also be assisting us with supply chain optimization and budgeting. Then construction site monitoring. Using AI-enabled drones or cameras, construction sites could be monitored for safety, ensuring that workers follow protocols, identifying hazards, and providing real-time data for decision-making. All of us are aware of in the real world, there are a lot of delays that happen. If you're planning to finish a project in a year, it never happens. So the other one is smart building systems. So once the building is completed, then you can monitor and manage lighting, heating, cooling systems in real time, improving efficiency and reducing operational costs doing this. Like, for instance, thermostats. I think we already have it. So I can control the temperature of my apartment from here in Mumbai, and my apartment is in New York. So I think that's where I use computational engineering and AI the most. And then personalized architecture, of course, like especially in domestic architecture, houses that we design are catering to the need of a particular family or a person. So that can be optimized. Also, just to share a little bit, So I have friends who work in machine learning, and they recently shared a video of a robot doing laundry and folding clothes for me. So I think that's the future that we want. Now, I would like to share some work that I did during my school at University of Pennsylvania, and also what I do in my job in New York. So this is a part of the polyhedral structure lab, where we were using robotic arms for fabrication. And it's basically done all on Grasshopper, Python. So this is a siteless house. And we were basically trying to develop these new constructional techniques using robotic fabrication. So over here, oh, this looks a little weird on the screen, I'm sorry. So in the middle, if you see, these are simulations that we were trying. This did not end up getting used, but this was our trial. And then this is on your left is the concrete block that we developed. This was a structure, which again was a part of the study. It was not something that we ended up using. And then that also is the cuts that we were trying to produce for this siteless house. So again, this is all a part of simulation that we did with robotic fabrication. Now, this is what was the real world integration of it. What you see at the bottom are the cuts in the foam blocks that we made to achieve what you see on the right. And this is like a real block. There are 2 blocks. Basically, this whole studio was concentrated upon developing these structural techniques. And these are 2 blocks, the real size blocks of the siteless house that we were trying to develop. And the techniques are, so basically, the concrete has been poured, and we were using foam core, and we were using foam core as also a part of structure so that it's lighter as compared to a whole concrete block. And then the cuts include, like this house was not supposed to have any external fixtures. Everything was supposed to be included. Be it the lighting, be it everything was supposed to be included. So this is what you see on top. These are 2 detailed sections. And these are the cuts that we prepared with the help of coding in Grasshopper. So these are the cuts that we prepared with the help of coding. And you can see that how robotic arm went through it. And now this project was I would use this as an example of the sustainability that we did, sustainability project. So this was done in Mongolia, in Ulaanbaatar, the capital of Mongolia, which is the coldest capital city in the world. The average temperature over there is -1 degree Celsius. And they were facing a problem, they are actually facing a problem of pollution from the nomadic lifestyle of the people who ended up in the city, but they did not want to leave their nomadic housing, which is called the ger, and would not want to settle down in the city, but they just got the whole, I would say, like, if you look at the picture, there are like 2 parts of it. One is the city and one is the ger settlement. And in this project, what computational design actually helped us with, this was also done on Rhino, and to calculate the energy. And this helped us to actually give the solutions to reduce the pollution caused by the gers. Then the next one, this is my studio project, and again, this was also, this was in Maya and in Grasshopper. So this is, we were developing a museum for Andy Warhol, the famous pop artist of the 60s. But we couldn't use Andy Warhol's paintings as an inspiration. We were supposed to use other pop artists. So we ended up choosing Yayoi Kusama, who's a pop artist from Japan. And what you see on screen right now is her work called The Infinity Room. And so basically this is polka dotted, the entire room is polka dotted with mirror in the middle. A cube which is made out of mirror in the middle. Now, that picture, we developed these arrow-like looking structures. So basically, this was the essence of the picture. We studied that picture, and we tried to demarcate it in the case of using arrows with like the direction signifies the something, then the magnitude signifies something, and the line weight of the arrow signifies something. So, and then reflected angles and broken angles were taken into account. So from this diagram that we created, we ended up choosing a part of it for our final project. And further narrowing it down, this was the part of the diagram that we picked up. And then we started doing our assembly studies. So this was one of the assembly studies that we did, where basically these projections point out in the direction of the arrows, and their thickness varies as per the thickness of the arrows. This was another assembly study. Then we used 3D printing extensively, and and this was what we were trying to see, like if it's going to work out in the real world application, or how our assembly studies are gonna take shape. Then these are the plans. So these plans were also informed by the assembly studies and the models that we created on the computer for this. Most of it was Maya and Grasshopper. So Andy Warhol, just to give a little bit of a design explanation, Andy Warhol was a hoarder. He would also keep the receipts from the soup cans that he bought. So these capsules that you see in the middle are basically they're basically storing all his receipts and all the material that he has hoarded. Also, this museum is not only a display gallery, but it is also a studio for the upcoming artists. So that is why it was designed to accommodate both, that that artists could use it as their studio, and they could display their art there. Then the program diagrams. This was the study, and this is this was basically the breakdown of the building program, and the section at the bottom. And then what you see, the big picture here is this is a 3D printed model, and it also used a lot of other fabrication techniques, like laser cutting and CNCing, and we tried to, maybe it's better on the next slide, wait. Yeah, so if you see at the bottom, this was the whole progression of our design in that studio. So it started with a diagram, and then the assembly studies, and then that's where we got our plans from, and then the assembly studies actually turned into the real facade, and the section. So, yeah. And this is this is Moynihan Hall, which is on the 34th Street Penn Station. So you ever come to New York in Manhattan, this is one of the major nodes for the trains. So what we did was, we actually redid this, we redid the roofs to make it more, to bring in more light, and also to make more space for the travelers. So this roof is what we did a lot of simulations for. Again, Grasshopper was our tool to work this out. And now it looks like this. So this is, we ended up working closely with the structural engineers to design a truss system to hold this roof. And yeah, if ever you end up coming to New York, please see this place. It's really amazing. And this is one of my favorite projects that I did. So this was the use of computation. This was based on use of computational design in fashion, using architectural and garment construction techniques both. So this dress was again designed in Rhino and Grasshopper. So the triangles that you see, the triangles that you see over here are basically thinner at the top, and then they become thicker, and there's a progression to them at the bottom. In this, we used silicone as a binder and tule as the structure. And then it was inspired from techniques of smocking, ruffle, and lace making. And then these are all 3D printed triangular pieces printed on tule fabric. And tule is the structural component, and silicone is binding it all together. And dress is an amalgamation of architectural and garment construction techniques, as I mentioned before. So yeah, this was another close-up. And we did this. This was, by the way, the showstopper dress at the Warden Charity Show. And the model, she was getting married, I think, 2 months later, and she wanted this as her wedding dress. So I think we succeeded there. Now, I'd like to end my talk with this sheet. It says, this is a famous quote by this Polish author called Joanna Maciejewska. She says that, it's actually a tweet. She said that I want AI to do my laundry and dishes so that I can do art and writing. And I think this was a point of discussion in the morning. And, but I would give my opinion, but I would also like to leave you guys with this question. That has AI made the work of architects more diverse, efficient, or redundant? To me, I think AI or machine learning, they are tools. They can be used the way we want them to. And I think this is one of the best times to be an architect in, because there's so much happening that you can actually see the change coming. You can actually be a part of this whole evolution that's happening. So I think diverse, yes. I think we have seen many examples of that. And efficient, yes. Again, but redundant, I think it's optional. It depends on the architect, and it depends on the designer, how we want to perceive it. Plus, the next question that comes to our mind is that what we see AI as versus what we perceive AI as. I think how we see AI as currently, it might change in the future, because I think the technology is evolving faster than the speed of light, probably at this point. So I think what we see AI as is a tool that helps us currently. I mean, ChatGPT, for instance, that is, I think, the most used AI tool currently. So people are using, like, for instance, I would say how I use it. If I need to search something in the codes, now I do not have to go through the 5 books of different codes that are applicable to a particular city. I ask AI, and it gives me specific codes. I at least have a starting point to check those books. And I do not have to skim through the 1,000 pages. So I think that's very helpful. And then what we perceive AI as, I think there are 2 kind of things. I think we are either eulogizing it or we are demonizing it. So again, that goes back to the first slide that I had. It can be a utopia in the future, or it can be a dystopia, but it's on us. And I'll leave you guys here with this. Thank you so much.
Thank you, Shitashi. It was indeed a very insightful presentation, and you set on stage the Government of India. He has self-published books entitled 8 2023 Comprehensive Subject-Wise Study Material for Architecture and Planning and Thesis Manual for Bachelor of Architecture. Merrifizer actively reviews human-level journals like International Journal of Tourism in Cities, Tourism Recreation Research, Gothic Business and Management, and Tourism Management Perspective. Merrifizer is also a session organizer at the SMUS Conference 2024. His professional affiliations include being an accredited professional of IGBC, a certified professional of GRIHA, and a member of ISRS COA and ITPI. He received the prestigious Graduate Scholar Award in 2015 and 2016 by Common Ground Publishing. He has delivered many guest lectures at knowledge building seminars, workshops, and faculty development programs. I welcome you, sir, for starting the presentation now.
Thank you, ma'am. Good afternoon, everyone. So, thank you, ma'am, for this warm introduction. And as ma'am has already introduced that my area of research is tourism management and planning. I look into the data and try to see how we can improve tourism infrastructure. My thesis was resilience and sustainability in tourism in India, and I worked in the national level where I studied 28 states and what were the disasters those states were facing, and because of that, how many what type of tourist, like domestic tourist or international tourist, were getting affected. And also what was the economic and the social loss because of those disasters. Here my work was both type of disaster, like I worked with natural disaster and the man-made disasters like political or internal conflicts or the terrorism. Then I worked on the personal level, tourist level data, like I wanted to see how sustainable Indian tourists behave while traveling, and also at organization where during the COVID time I wanted to see how resilient Indian hotel industry is. So giving you a brief idea, because here also I am going to talk about AI driven smart urban envelopes for sustainable tourism infrastructure and smart cities. So the objectives of this session are to develop an AI-driven framework for optimizing architectural envelopes in tourism and smart cities, ensuring sustainability and efficiency, and to analyze the policy implication and future achievements in AI integrated urban resilience and smart infrastructure. Many of the examples which I'll be talking about are, few of the examples are from my ongoing research, and few I have taken up from the already known case examples to show you that how we can move ahead in research field in concerning to AI. So this is the structure of my session. I'll start with the introduction and research context. So here we are going to talk about the background and rationale behind it and the research objectives. Coming on to the first one, the AI in architecture and computational paradigm. AI-driven parametric modeling, predictive analytics, and generative designs are reshaping the architectural practices. We have seen there are a lot of data-driven or self-optimizing models in architectural envelopes, and they are actually using these data. We are able to see whether how the cities or the building envelopes will be reacting, and especially reacting in a place or setup where we are trying to see how we can convert our cities more or make them more smarter and also improve the tourism infrastructure. AI in built envelopes. AI enables real-time data processing, data twin simulation, and also performance-driven adaptive facades. AI optimizes the energy performance, microclimate adaptation, and also the material intelligence. I'll be talking about these the areas like the performance, the sustainability, energy efficiency, and all in coming slides. So this is the research gap which I could understand and identify the lack of integrated framework as of now. The existing research lacks the structured methodological approach for integrating AI-driven models in architectural envelopes for tourism infrastructure and smart cities. Need for interdisciplinary approach like combining AI, urban planning, and sustainable strategies to inform policy and practice. So these are the ones which I could identify as the research gap. Then coming on to the research objective, I wanted to develop a comprehensive methodological framework. So here to establish an AI-driven smart urban envelope and integrating it with the machine learning, generative design, digital twins, and the parametric optimization. We all know that the AI has a lot of application in smart city planning. India also under the leadership of PM Modi, we launched this smart city initiative mission in 2015, and there were 100 cities which were identified, and we know that these are the applications like right from the smart parking to the traffic control to the open source big data and or the monitoring how the buildings or the city reacts at a particular time of day. Then the third research objective is to examine the policy implication and urban resilience and their strategies. So here there are the key factors which affect the smart building integration, like economic opportunities, resilience of city crisis response, citizen engagement, sustainable development, improved quality of life, enhanced efficiency, and infrastructure management. Coming on to the second section, that is the theoretical and framework and the literature review. So here I'm going to talk about two things: the AI integration in architecture design and urban planning, and then theoretical constructs in underpinning AI in architecture. So there are a lot of existing research on AI-driven design methodologies in architecture, and we know that we have some idea, and then the prior knowledge is also there. Based on this, we use human and AI to come out with generate some kind of AI-driven design and which can help us in understanding the problem as well as coming up with a better solution. So these are the ones, and then we already know that there is a lack of research in AI-driven adaptive envelope for tourism infrastructure. For this, we have comparative analysis, manual versus AI-driven optimization in urban environments. The two things, the first one, the manual design approach, here it relies on the rule-based decision making and the static simulation. This is what we are generally doing at present. And we face challenges in scalability, the real-time adaptability, and also the integration of complex data sets. The data sets which are very large. But with the help of AI, what we are able to do, we have more informed data, we can predict and adapt to the approaches to architectural design and use machine learning algorithms and evolutionary models for real-time decision making. So, and also AI is helping us in enabling climate responsive, energy efficient, and visitor friendly urban environment. Coming on to the second part, the theoretical constructs underpinning the AI in architecture. So the first section is the machine learning and deep learning in built environment. AI, you can see this first part over here. This is what we generally used to do. using, this is one example from the design builder, but with the help of AI, we are able to do the complex simulation and also come up with more informed solution. So one of the case example can be the AI-driven energy simulation in optimizing models in smart buildings, which we are already, many of us have started working on it in this field. I'll like to show you another example, like generally the process is data collection, then data pre-processing and model selection, objectives and the application. But with the help of AI, we can see that we have more informed, we can analyze larger data set and can infer from those data set like how to use this data. Every day, I always see that every day we generate like many different types of data. Our body temperature, when we are traveling, our travel behavior, the traffic red lights and everything. We are generating lot of data, but are we able to use those data properly is something which we can use, but we are probably not being able to use it because of maybe because of our there is a gap in the knowledge, maybe because of the methodology gap. So we can actually use AI in solving all these problems. Then finally, the second part is the generative design and parametric design. Generative adversarial networks, GEN networks, and the evolutionary algorithms in form finding and material efficiency is one thing, and then the applications can be something like climate responsive tourism infrastructure in adaptive smart city envelopes. So again, this is kind of how it works. So we have fundamentals of GEN network, then we have the literature search, then we have applications in construction field, and then we have the future work like ethical consideration, model improvement, predicting model proposals, and integration of AR, VR, etc. The third part of the theoretical construct is the digital twin technology in architecture and urban planning. So here we have, as I was talking about, the real-time monitoring data and the predictive analytics for building performance optimization, etc. And then we have AI-driven digital twins for visitor flow management and environmental monitoring and predictive maintenance. So again, we have lot of data. Like when I am talking about the tourism, and we say that this many tourists visited India because of medical reason, because of like to meet friends and family, or for business reasons, what extra can be done, or how we can make them spend more money in India so that the tourism receipts can be more. So one case example can be the smart urban district leveraging digital twin model for adaptive urban infrastructure. The fourth and the final part of theoretical construct is the climate adaptation and sustainability theories in AI driven architecture. Urban resilience frameworks and AI's role in mitigating environmental stresses. Then we have like we can analyze the urban heat island, flood risk, and carbon neutral design strategies. So the case example can be something like AI enhanced sustainable tourism models in climate sensitive zones. So these climate sensitive zones can like we can see like what Kerala is doing during the peak monsoon time, and then what Uttarakhand or Himachal Pradesh is doing during the rainy seasons, because there is always a risk of us as a traveler getting trapped in those areas. So what extra can be done to make those tourism destinations resilient? I will come to the methodology section. So AI driven framework for smart tourism envelopes. So here I am going to talk about two things: the design research, research design and approach, and then the AI enabled methodologies for smart tourism infrastructure. The first one, multi-tiered AI-driven framework for smart urban envelope. So here we can see that we have some physical facility, then we can use data and the central database cloud control over here. and then we can come up with the digital twin and see what if we change one parameter, or if we change two parameters simultaneously, what will happen. So using these kind of analysis, we can actually simulate real life problem, like this Kumbh Mela is happening in Allahabad, and the work for this crowd management started in 2021, and it was given to ENY, and they did lot of different type of simulation. And because this is unprecedented to see 3.5 crore people, 4 crore people coming into a small city of population 30 lakhs. So 3.5 crore to 4 crore population is the combined population of Delhi and Mumbai. So these kind of analysis can be done, and then we have quantitative and qualitative approach like performance simulation. So we like the building performance simulation, and then energy, for energy efficiency, shading and ventilation control, these can be done. Case studies and empirical evidence, there are a lot of these kind of examples, like AI integrated tourism infrastructure across smart cities and heritage sites. Then we have comparative assessment of AI driven optimization and conventional approaches in urban resilience. So here we have three digital twin data which is coming from three different categories. Like the first one is the physical asset, then we have virtual asset, then we have the different services. Services like acts and change, then predict and plan and analyze and comprehend, and then describe and monitor. So these are the building, this is how building performance simulation work. One more example is the agriculture field, like advanced computational fluid dynamics application in agricultural building model. So here we can see that we are using different data and trying to see how we can improve the crop quality or the output, and then come up with better agricultural output at the end of the year season. Coming on to the second part of the methodology. So first is the generative AI for tourism infrastructure. So here you can see there are two types of architecture. So first is the discriminator architecture, and the second one is the generator architecture. So in generator architecture, generally the latent space generator and then the generator image is used. In discriminator, it is real image and generative image, both are used, and to see whether it is real or fake. So gen and evolutionary algorithms for adaptive design and generation and performance design form findings. So one good example is the AI generated climate responsive hotel facades in Goa and Bali. So responding to the humidity, wind load and solar exposures. Second is the digital twin technology for real-time decision making, like AI-driven congestion control at Jaipur's heritage precincts and Venice's tourism hub, reducing the overcrowding and environmental degradation. So what is happening that if there is a congestion, then traffic will itself, like the red light areas will itself start showing like more time. So if you see that if the red light is there for say 5 minutes, then probably you will take turn rather than going straight. So they are decongesting the traffic like this. Then we have AI based facade, adaptive facade and smart envelopes. We have seen this example in lot of places, and this is Al Bahar Tower in Abu Dhabi. So again they have used reinforcement learning. So it is RL, just like ML, which is machine learning. So algorithms are used for kinetic facade and adaptive envelopes. So this AI optimized hotel envelope in Dubai and Singapore, featuring dynamic sun shading and AI driven natural ventilation. So how it works, like you have the system input, then it processes, then it finally gives out gives an output which is more energy efficient. Then the fourth one, the machine learning for sustainable energy optimization. So this is a very good example, eco resorts in Maldives. So AI-driven optimization for eco resorts in Maldives, integrating solar power, wind tunnel, and AI-powered passive cooling system. And these are mostly the tourist places and the resorts where they are using this technology. Again, there are few more examples. I will not go into detail about this one, but yes, the fifth one and the last one, AI-driven policy and urban resilience in smart cities. So here, in one of the good example, even one of my research paper was on this Himachal Pradesh itself. There I wanted to see what kind of different type of tourism the Himachal Pradesh is facing. But this is related to the understanding Himachal Pradesh's resilience in terms of landslide prone tourism zone. Only one factor is being considered, and that is the landslide, how prone the Himachal Pradesh is. And we can see based on different factors, and if we change parameter, which are the areas which are critical. So we can see over here. So these are the hotspots where a lot of infrastructure development or the resilience needs to be, it should be made more resilient so that it can cater to more tourists. So results and the key findings. Again, I have divided into two parts, where first one is the performance analysis and AI driven envelopes, and the second one is the benefit and challenges of AI in smart cities and tourism architecture. So first is the conventional approach, where we are doing these days, like the static, then the rule based design methodologies with limited adaptability and environmental changes. Whereas energy intensive operation due to are not possible due to lack of real time optimization. These are manual design iterations and needs lot of time and also are very much resource consuming. Whereas this is the AI driven approach, where we can see generative designs, design algorithm, optimize spatial configuration for climate adaptability. Machine learning models predict and enhance building performance, and also the digital twin provide the real-time feedback, allowing the proactive maintenance and energy management. Second part of it is again the energy efficiency, where the case example which I have already discussed, the Al Bahar Tower. And because of this adaptive hotel facade, in almost 30% energy could be saved using the AI-driven dynamic shading system. Similarly, the sustainability, coming to the sustainability part, the AI-driven eco resorts in Maldives implemented the machine learning-based energy modeling and reducing the carbon footprint by almost 35%. The third one is the cost effectiveness. The Venice's AI-driven visitor management system minimized tourism-related congestion, and thus it reduced 20% maintenance cost. The key benefits, like first one is the improved efficiency. So because AI helps us in coming up with a good informed decision making and automated parametric simulations, replace the labor intensive manual modeling, and thus reduce the design time by 30 to 50%. Second one, again the Al Bahar, where the AI powered kinetic facade in Dubai could adjust to the real time situation, like whatever is the time of the day, it could change its facade projection accordingly. Then the sustainability and predictive accuracy. So AI enhances the climate resilience by integrating weather pattern and predictions and energy efficient envelope designs. So coming on to the second part, that is the benefit and challenges of AI in smart city and tourism architecture. The first one is the data challenges and limitations. So data dependency and computational complexity. Yes, this is very important. If we don't have data, so because we have to train our model with a lot of these kind of data which can be used in analysis, and if we don't have this kind of data, then the predictions cannot be correct. So this is one thing. Then we have second one is the ethical concern and design limitation. Like there is always a risk of over reliance on AI driven design, potentially limiting our human creativity. And then we also have the ethical concerns in data privacy, AI bias, and equitable distribution of AI driven infrastructure solution. So in fact, since I'm coming from Delhi, so we have lot of central government agencies. So 5 more minutes. So okay, ma'am. So because of this, the government has already issued a circular that the government officials cannot use AI for the sensitive information. So we have this kind of limitations or ethical concern as well. Then the third one is the implementation barriers, like limited expertise in AI driven architecture among professionals, requiring capacity building initiatives. So we need to first develop our professionals who can use AI in a better way, so that we can come up with a better solution. The fifth section, second last section, the policy implication and future direction. So a few recommendations and the future directions, I'll be talking about these. So the AI driven urban policy for sustainable tourism zones. Like one example is AI driven real time crowd monitoring in Venice to prevent tourist saturation and protect cultural heritage. So this is a very good example where the first one is the pushing behavior. Then we have visualized example of annotated video using this approach, and then finally we have visualized example of annotated video stream. So and then finally we are coming with the CNN network, that is the convolutional neural network solution. Second is the adaptive building code and AI integrated architecture. So we have Singapore's Green Mark certification framework integrating AI in performance and monitoring tourism development. I'll not go into this, but here what we are doing is, like, we have on one hand we have smart city, and on the other hand we have smart building. So data related to the city level data is used for training or coming up with a good solution for the city, and then building level data is also used. Then we have this Himachal Pradesh resilience planning to make it more resilient to different type of disaster. Mostly here I am talking about the landslides. Then we have government policies. We have already discussed about it. I'll skip through few slides because of time limit. Then finally we have coming on to the conclusion and discussion. So the summary of the research framework, findings, and the policy contribution, and I'll also finally open this discussion with few questions which we can try to answer through research. So research framework and methodology is the so here we talked about the multi-tiered AI driven framework, AI driven envelopes, and quantitative simulation and real world case studies. The key findings are like AI enabled generative designs help climate responsive material efficiency and spatial adaptability. Then we have digital twin technology, machine learning models which can assess urban heat island effects, flood risk, carbon neutral strategies, and also support the resilient tourism zones. And then finally we have policy contribution, like how we can use this in preparing policy at the government level or to for ethical AI adaptation. So finally I'll these are the few way forward research questions which we can try to answer through our research. So first one is the future implication, like will AI complement or replace the traditional design methodologies? How architects and planner effectively integrate AI decision making while preserving design creativity? Then we have challenges and ethical consideration. Here again, there are two research questions which we can answer. How data privacy concerns and computational bias and AI transparency can be addressed using AI-driven architecture. What are the long-term social, economic, and environmental implications of AI integration in urban development and tourism infrastructure? And the third and the last part is the research and industry collaboration and opportunities. So here we can try to find areas for interdisciplinary research, merging AI, sustainability, and human-centered urban design. And finally, the strengthening public-private partnership for scaling AI-driven smart city solution and tourism innovation. So these are the few questions where we can work, and I have seen that these are the areas where very few researchers are working. So these are this can be taken up as research areas. Thank you.
Thank you, sir, for your in-depth analysis and thought-provoking discussion on sustainable tourism infrastructure. Next, I request Khushbu Davda, architect Khushbu Davda, co-founder Studio Emergence Mumbai, to present on the topic Unfold, Technology and Collaboration in Design. Khushbu Davda, senior principal architect and co-founder of Studio Emergence, has spent over a decade perfecting her expertise in parametric design with a clear vision to create spaces that enhance the experience of living. For Khushbu, architecture is not just about functionality, it's about crafting environments that resonate emotionally with those who inhabit them. She believes that the true power of design lies in its ability to evoke feelings, whether it's warmth, calm, joy, or a sense of belonging. By carefully balancing form and function, Khushbu creates spaces that are both practical and deeply emotional, ensuring that each environment is not just a place to live, but a space that connects with the soul. Under her leadership, the Mumbai-based studio has delivered and continues to work on groundbreaking projects, including the hybrid planetarium in Visakhapatnam, India's tallest company tower in Rishikesh, and landmark residential developments for Suji Group and Shriji Sharan Group. Known for her ability to translate nature's complexities into innovative architectural solutions, Khushbu's work balances cutting-edge geometry with functional elegance. A prominent keynote speaker and panel moderator, she's a trailblazer driving the evolution of parametric design in India, setting new benchmarks for the field.
Laptop ही नहीं है.
Over to Khushbu.
Yes, hi. Thank you so much for a kind introduction. Today I'm going to talk about practical implications and how we are actually using design in our studio, AI-informed design. I hope you enjoyed this discussion. I will not take up much of your time. ठीक है. Extend कर दो. I got it. नहीं है, नहीं है ना, वो था, मैं चालू कर दिया था, बट sorry for the little technical glitch. Yes. Yes. Hope everyone can see the text clearly now. So our studio basically works with different geometries. We work with physical and digital way of technologies. We didn't start working on AI suddenly. AI has become the talk of the town very recently, but I think architecture has evolved through different technologies like BIM and computational design methodologies, which also had machine learning in various processes. What I would want to start with understanding why should we use technologies for the future. What is happening is when you talk about any new technology, every other industry, including your automobile, your education, your manufacturing, anything you talk about, they will be the quickest to adopt any new technology, whether it be robotic arms or AI. But when it comes to construction, the real estate industry seems to always be the last one to catch up. So in this I think era, if we as architects and any of the other stakeholders, we actually are able to grab this opportunity of AI and the various methods that it has to offer, and even other technologies which go hand in hand with it, I think we'll be able to make the process of architecture and construction much more optimized, which is the need of the hour. Not only in our architectural studios, which take up a lot of time, and all-nighters, all of you are used to being pulling off, but even in construction where we need the materials and your manpower to be optimized. So these are some of the processes which is already existing in the industry, and I would not want to elaborate since both of our previous speakers have really elaborated on it very beautifully. I want to stress on the fact that this is how currently in our architectural studios AI, and not only in architectural studios but also in education, AI is used the most to create visuals which are just appealing and don't mean much, but just are food for thought. It might not be the most efficient way of using this technology, I would say. But we do have an example of how we have managed to use this technology in a process of design, and still were able to create results which are an amalgamation of creativity from the architects and some help with with AI technology. So this is a beautiful site we have in Rishikesh. It's a resort that we are building there. So you can see, if you can see the entire, the river of the Holy Ganga from here, and this is the entire town of Rishikesh, which you can see from here. Yeah, you can see my mouse cursor. So yeah, so we have this really beautiful site, and we as a studio, as partners, me and my partner Sija, we really started working with sketches and making sections, because it's a very complex site. It's a 1:2 slope, which is sort of unheard of in urban scenarios. So we started making sketches, but some of our interns in the studio actually started working on Midjourney, and they came up with these examples. It really ruffled our feathers, because we are used to using tools which are much slower in giving results like this. So what we did was, we thought that why not use this as a base for understanding the contours of the site and come up with results which are much more interesting than our slower methods will come up with. So we use some of the elements from this to actually come up with beautiful results of in the plan that we were working with. And this is actually our work in progress actual model. This is a 3D model in Rhinoceros, which we have made with use of computational tools, of course, like Grasshopper. But it was a slightly disjointed exercise. I wouldn't say that it was completely seamless, because we still are, trying to get the hang of how to actually join the dots, because all the softwares currently on the market are having, different kind of techniques, which there is no process which are completely seamless. So, but we still managed to get some results which are quite seamless, and of course, creating different views. We have these cottages which don't look at each other, and are still, you know, seamless integrated with the surroundings. So I think we are there, and this is a work in progress model which I was very excited to show how beautifully it is inspired by the prompts that we have used in Midjourney. So of course this is a very nascent example of how actually studios can benefit from AI. When it comes to other techniques like computational design, what we actually understood is trying to understand systems from nature is of utmost importance, because nature has already optimized and it already has an AI engineer in their entire ecosystem, which is built throughout millions and billions of years. So, you already must have seen these kind of murmurations in nature where birds, a flock of birds create these beautiful patterns. And you can always, come down to these really nice components of it, which is rule-based. So, I mean, you would not think of something so beautiful as rules, but, you can always break it down into mathematics. So that's what we managed to do over here. We try to understand the geometry of how these birds follow these very simple rules of separation, alignment, and cohesion, such that they use minimum energy to fly and create these patterns, but they don't always collide to each other, and they don't separate too much from each other, so that they are able to spend minimum energy to fly or even migrate from one city to another. So we tried to understand their behavior, how these flocks work. You can see in these diagrams how these birds are creating, slowly creating these patterns when more and more birds start migrating to one herd. So this herd behavior is sort of a system which comes from emergence. Emergence is a word which is coined by Stephen Johnson. He was an author who has written this book called Emergence. It basically says how it's a system which is seen in nature quite a bit, and even now in computers, your brain, and even in cities. So you must have seen ants. They are, they form a line, and they move sort of in a line. It's also a beautiful example of emergence. A flock of birds, school of fish, all of these again are examples of emergence. Even desert sand, these patterns that you see on the sand dunes, they are also emergence. So what we understood is, if we understand flocking behavior really well, we'll be able to really illustrate the example of relationship between a group and an individual by mimicking a swarm of migratory birds, to understand how actually we as humans also try to live autonomously within societies defined by rules and conventions. So it was a very beautiful example we could actually create physically. It was a very beautiful site we received in Chandigarh. And Chandigarh, is a land which is built by Le Corbusier from scratch. And of course, we are really huge fans of Le Corbusier. So it was really interesting for us to get this site, because this was the only chalk which Le Corbusier had himself designed. And it's the biggest chalk in Chandigarh. It's called the Matka chalk. Next time you're there, you're definitely going to notice this chalk. It's almost 100 meters in diameter, and it has the Rose Garden, the Housing Board, the Taj Hotel, and Natural History Museum flanking it. What we did was create a sort of murmuration of birds on the sides of the matka, so sort of, poetically illustrating birds flocking on a pot of water. And we actually froze the murmuration in time, created these installations with metal birds and metal rods, which are almost 2 to 3 floors in height. This is how the installation looks right now. It was a very interesting and challenging exercise we did in the middle of the pandemic, actually. But yeah, this is how it looks right now, and we're receiving really good feedback of how the city is responding to it. What we do as a studio is when we are trying to navigate complex geometries and complex forms, it is not always possible to do that directly in your projects. So we create these installations as art installations, which is a part of our studio, where we understand geometries, we understand how facades work, we understand how you can actually build complex structures without having to invest, or the client having to invest directly in it. So we did this really nice installation in the Nehru Center in Worli, I think 9 years ago, where we had created this sinuous curve, like a wall which was made of sine curves, which makes it structurally very stable. And we actually created this kind of simulation on top of it, which was made of pine cones, which was actually frozen in time to optimize the solar radiation in winters and minimize the solar radiation during summers. So this is how the facade can, look like and perform. And of course, the scalability of modules is always something that we can look on. We really love experimenting with geometry. So minimal surfaces is, one of the most thought of and researched geometry. We thought, why don't we experiment with that? Because it gives these really lightweight structures which can span across a large area without having the need to have any columns or beam structure, which can be the future of architecture, right? Lightweight structures. So this was a gyroid which we have, decoded and tried to understand this geometry, of course, with the help of Grasshopper and tools similar to it. This was a process where we actually understood this pavilion we did for IDAC Expo. It's an expo in Mumbai where there's a lot of architects and designers actually come together. So this was the urban pavilion space that we did. It was 10 by 12 meters, and we made this entire pavilion, which was digitally fabricated into 13 parts, which were made at our office actually, and we transported it, and this whole installation was finished within 3 days with the help of our team members, of course, and a few contracting teams. So it was a fun, challenging exercise because 3 days is really very, very, very challenging on site. You can see us working day and night in this video. But yeah, it was a fulfilling exercise because it was a doubly curved surface which we managed to put up in that expo. So when it comes to actual architecture and tall buildings, because we are in Mumbai, right? This is the need of the urban fabric. How can we actually use AI and computational design tools to actually create buildings which perform better? So these are ongoing examples of certain projects that we are doing in the office. We are using this geometry called the catenary surface. The catenary is a surface which is made famous by Antoni Gaudí. He's an architect based out of Spain. He's the architect for the Sagrada Familia, the famous church which is always under construction, hopefully be done after 100 years in 25. So yeah, this is the Sagrada Familia, and you can see this module that he used to do with physical. And of course, now with the advancement of tools and technologies, we are able to do it in Bombay in our office very close to here. So of course, we didn't have to create those catenary models with hands because we can always simulate it with this geometry and the tools that we have. It's a very simple geometry, but it's one of the most stable arches that you will see in nature. We have manifested this surface in crown of a high-rise building we are doing in Kandivli in Bombay. It's one of the western suburbs, northern western suburbs of Bombay, and it's almost a 60-story. It's a 58-story building, and the crown of this building is going to be like this, which is the amenity space and your penthouses and all of that. We even actually did wind analysis of this geometry, and it performed much better than a regular rectangular geometry. So in a urban scenario like Mumbai, where you have a lot of wind, almost more than 3 kPa, it performs really well. So we also, of course, manifested that form on the commercial level, which is on the top of the podium of the residential level on this. So we have a mixed-use building with the catenary surface being the hero. This is form optimization through radiation. Now, radiation is, of course, a huge problem, like in a tropical country like Mumbai, in a tropical city like Mumbai. So what we have done is trying to understand in this commercial building that we have got, again, this is in Borivali in Bombay. So very, very local understanding of the climate was required. So what we understood is you can always get data, right? You can always get data of Mumbai from, and you can actually understand through the context, because your intuition and your knowledge of architecture will always be restricted by your time and your data. And what happens is, if you are able to manage to get the data of the surroundings, of the heights of the buildings surrounding it, you will be able to create your buildings, the performance of the buildings, which will be much, much deeper. So we made a genetic algorithm to understand if we can, reduce the radiation of the commercial structure. And we did manage to do that with some twisting of the floor plates. Of course, it's a challenging process to build that, but the main structural geometry doesn't change, but the slabs are twisted in such a way that we get this morphology, which is very beautiful and manifests into a nice biophilic structure. And taking a step further, we want you to understand that architecture is, like a translation of your thoughts. Now, the only drawback is the translation of your thoughts take a long time in architecture. So again, for this project that we had in Bombay, it's a 60-story structure, and the planning itself takes a while. It's a SRA structure, so you can understand that that it has a lot of rules and a lot of regulations that we need to adhere to. So as an office, which is a mid-sized firm that we have in Ville Parle, we wouldn't be able to create all of this in such a short period of time, so as to even bag the project. So what we did was make a lot of sketches, understand the plan and the massing quite deeply, and then generate these different forms of crowns which can create an iconic building. We wanted to actually, this is the massing of the building, which is, it can be really jarring to the eyes because it's massive. It has 12 apartments per level, and 2 4 BHKs in the center, which is like a massive building. So we wanted to actually break it and make it look like there are 2 towers. So that's what we managed to do that in these options. And we are really happy with the results, because we got a couple of results which were really something that we would like to go ahead with. And the client also managed to like this one. So that is how, we have manifested a very fast creation of a lot of options. But mind you, this was all because of the inputs of the architects in our office. So everything was thought of, only the simulation of how the renders come out to be, that was done in AI. And this is a pure exercise to come up with a video of how the options have come up, because we did make a lot of options, which is not usual in our studio. So this is how actually the crown is manifested to be. And because we know and understand that it has to be constructible, we have actually optimized the form to make sure that this geometry has least amount of doubly curved surfaces and more planar surfaces. I'm going to quickly go through a few collaborative projects that we are doing. We are doing this project with architect Hiten Sethi, where we are the parametric consultants. What we were given is a plan where we have to create these dome structures. So these dome structures have to be constructed on site right now. So we had to, generate the geometry which can be actually executed with the help of really basic tools. Please understand, to create this geometry in India, it has to be really dialed down to the most basic geometries which your structural engineers and which your fabricators are used to. So we managed to do that with these nodal grids which we formed, and we pinched the grid just near the entrance so that the complexity is removed. And this is how the complexity was lessened to the most basic extents, and you can just bend a pipe in your bending machine, and then you can get this geometry. It's currently, this is the status of the building. It's in Kharghar, it's Navi Mumbai, and if you are going to visit this next year will be a good time, because that's when it's supposed to open. The hybrid planetarium in Visakhapatnam is one other example where we are using complexity with minimum resources, which we have gotten in the city of Visakhapatnam in Andhra Pradesh. The concept was a black hole. We wanted to actually understand the geometry of the black hole, which it doesn't exist, right? It's a gaseous form. But NASA had released an image of the black hole, which was very beautiful to us. And we thought, why don't we manifest a geometry out of it? So we came up with this 3D geometry, which could look like a black hole from two angles. One is the entry, and one is from the city. So this is the angle from the entry, where if you remember that image from NASA, it had come with a, like a slightly black center and these rings which are forming next to it. So we have manifested those rings with the form of LED lights on the on your structure, and your planetarium dome is supposed to be an LED screen which can go from dark to any kind of image on top. This is how the structure is optimized, and of course you have to have different kind of digital tools to help you create these geometries, otherwise it can get complex during construction. But yeah, I hope I finished this on time. Thank you for your time. If you have any questions, please feel free to ask me after the session is over during lunch. Thank you so much. Thank you for having me, Uzma.
in which the emotions are converted into quantitative data. So one very easy example is the behavioral analysis. So similarly, the emotional analysis is also there, where you quantify all emotions into numbers, and then based on those numbers, you can come up with the informed solution. So one good example was, even I have done, is the willingness to pay an extra charge or tax for Indian travelers because they don't want to change themselves from buying plastic water bottle. But they want water bottle, so they are not changing their behavior, but they are ready to pay an extra money. So similarly, there are a lot of studies where you can quantify this. So you go, the best way is the behavioral economics. If you want to really study it, you study the behavioral economics, and then you can quantify the data. So it's very simple. One very maybe now outdated methodology is the structural equation modeling. So you can use that. Yes, yes. There are, if you visit Ministry of Tourism and Statistics, so you will find few reports. So there, they are analyzing city-wise. Presently, they have analyzed Banaras and Shimla. Yeah, so they are coming up with those AI models, and for Banaras, it is a completely heritage city. So they started with Banaras. Right now, it is Shimla, where it is heritage plus lot of other new age development is happening, and Shimla is facing many problems like water scarcity in 2018. Shimla ran out of drinking water, so there are a lot of issues. They are using these reports are available. You can go through it, and it's very interesting actually. Yes, net zero, again, we can see net zero cities or buildings, or even the net zero campuses are being talked about these days. So there a lot of AI driven data are used. So in smart city initiative, there is one initiative called as ICCC, integrated cloud computing. So there presently it is at very nascent stage. In India, all the cities, they are just using that ICCC for issuing challan, vehicle challan at this moment. But there are larger use to it. So Kanpur Smart City has come up with the idea of using it to identify the different, all the residential, different type of buildings, the age of the buildings, and based on that, they can actually say that, okay, these are the buildings which might need restoration work, or people have to be evacuated. Because these kind of problems, Kanpur is an old city. It was one of the commercial hub of Uttar Pradesh, second largest city when India got independence. So they are coming up with these kind of things. Apart from that, I'm forgetting the name, one smart city in Telangana. So they are using that for agricultural produce. So there are a lot of small initiatives taken up by the like the city development authorities for integrating AI.
So when you're asking about AI integration in terms of sustainability in urban scenarios like Mumbai, I think it is one more tool that is helping us. Now the problem is in Indian cities, the challenges of sustainability run much larger than somewhere else. What happens is just to get the materials and the technical details right for that certificate. Now whatever developers are doing is actually flying the materials from Germany and Austria, which is defying the main purpose, right? So we as a firm are strong opponents of just the certificate. We would want whatever is available locally first, and if it is not available locally or manufactured locally, then your certificates don't matter. So that is what we are strong, this for. But technology is definitely helping in optimizing the time, the material required, and the quality of construction that is happening in India currently, because it is eliminating the technical know-how to the end labor. You don't need to be really smart or educated to actually implement these technologies now because of AI, which is great, I think, for a country like India. So I think we just are looking at, right now we are just scratched the surface of what we can be as a developing country in the future. Yes, that is majorly. Some of you who haven't heard about this question, optimization of the form of the building through computational techniques, is that something? Yes, that is what exactly I explained in my presentation as well, where we are doing that with a few projects of ours. And I think sustainability starts from your design board itself, because if you are trying to understand, if you have understood the context climate-wise and culturally, and what the user is going to do in that building, that is the first step towards sustainable buildings. So materiality comes the next. So I think these two, when we nail it in the design board itself, I think we are winning half the battle. And then the construction challenges comes with its own set of hurdles, which we need to, of course, pass along with your other stakeholders like your clients. So the first part, of course, it is 100% non-negotiable, but the second part is sort of still, you have too many players. So we are still not able to completely keep that under control as a practice of mid-sized firm, but I wouldn't be able to comment on other things.
I can talk about what's happening in United States, and yes, we are aiming for net zero buildings, and we are also aiming for buildings that are also giving back to the environment. So I personally, being an environmentalist, so LEED is one organization that gives you those certificates, but also there's another one which is called Living Building Challenge, if you've heard about it. So like LEED is about doing the least amount of damage, but Living Building Challenge is about giving back. So a lot of times, and they rate their buildings in petals. So a lot of times we try to make our buildings sustainable to that standard. And on a micro scale, I feel we can see it in our everyday life that AI, not just AI, I mean like the technology in general is helping so much. Like for instance, we used to drive to different places just to see our clients for meetings. Now all that is happening on Zoom, all that is happening on Teams. Then because everything, we're using iPads to check all these, to do all the QA, QC, and printing is so much less. So we are wasting much less paper. Then a lot of things have gotten at I think it starts at a micro scale and then eventually it just moves. So yes, we are aiming for that. And a lot of buildings are not just LEED certified, but are genuinely sustainable. Thank you. Hope that answers your question.
Yeah, I think now I have a question for Mehboob sir, first of all. How can AI balance the efficiency driven demands of smart cities with the unpredictability in terms of the sustainable tourism management that you have talked about? You've talked about the core principles. So there are other consideration in terms of if you're talking about community and unpredictability on ground, then lack of information which is there in the public domain. So how do you deal with such challenges on ground?
So the best example, ma'am, is the Kumbh Mela which is happening. So we don't exactly know how many people will be arriving. Last time it was when in Allahabad it happened, the maximum number of the devotees which in a day visited were around 1 crore. But this time it has exceeded by 3 to 4 times. So before even starting planning for this huge, big event to manage, they like the ENY didn't had any baseline like how many people will come. So, but they could manage it tremendously well, considering the different bay areas, the holding areas. Each holding area, even if you say that we will have holding area of 1 lakh people, but then also we needed almost 300 to 400 holding areas. And to hold people and then release people one by one, like one bay will be released, how much time it will take, and then you have, every day you have VIP movement. 2 days back, PM Modi took dip. 2 days after, President Murmu will be taking the holy dip. So we have these kind of big VIP movements. And again, this is just AI, where they have used data, like scenarios, different scenarios. What if 2 crore people visit? What if 3 crore people visit? What are the strategies they will be using? So the most likely now at present they know, okay, 26th of February, maybe around 7 to 8 crore people will be arriving. But before even starting of this Kumbh Mela, nobody could have guessed that on second day it will be 3.5 crore people visiting.
So in seeing those contexts, do you think there's something that we should purely rely on? And in terms of talking about digital management or any other aided thing which is there. So intelligence basically in terms of human intelligence as well as machine learning and all these things can also help in work competence.
Correct, yes.
Any ground experiences that you face?
Every day we are using Google Maps to travel. Maybe 1 year back, even if the Google Map used to show red on some routes, still we used to take. But these days it is showing red, and along with it, it is showing plus 1 minute, plus 5 minutes. So we know that there is a huge traffic jam. So this is how the machine, this model has trained itself, and now it is giving us more accurate data, and we can rely on it. So every day it is evolving, and we are using it in our daily life, knowingly, unknowingly, we are using it, and we are actually relying on those data.
Now, this is a question of both Shakshi and Kullu because something or the other, when we were talking about projects, it kind of, so as if we also talked about Shakshi, also talked about feelings and emotions, and then Kullu built on all how concepts can be also related to their journey and talked about these things. So, my question is as AI continues to reshape architectural design and urban planning, as Sir Rizvi pointed out, how can we ensure that integration is also enhancing creativity? Like we saw Definitely, I think that's something to ponder on. Thank you, Shitakshi, Nefus, and Khushbu for such exemplary presentations. Your perspective truly highlights the evolving role of AI in the domain of built environment and shaping our future. We appreciate your expertise and the thought-provoking ideas you've shared with us today. Now, as we conclude this engaging session, we hope that the insights today, shared today here, inspire new conversations and ideas in the field of architecture and artificial intelligence. We now take this moment to honor and express our gratitude to our distinguished speakers and moderator. We request Professor Veera Maligaonkar, our esteemed principal, to please take our guest. And we expect a huge round of applause from the audience as well.
check, check. Check 1, 2, check. Check this, check. Check this one, check 1, 2, check. Check. Check 1, 2, check this one, check. Check this one, check. Check 1, 2. Check 1, 2, check.